So we've talked about what inverse functions are, right? Basically, it reverses the y and sends it to the x. So a function sends x to y, inverse function sends the y back to the x. And we talked about the two properties of inverse functions. When you compose f with f inverse and plug in y, you get y. Basically, f and f inverse cancel. And when you take f inverse, compose with f, and you plug in x, you get back x. So basically, they're f inverse and f cancel. So now we actually want to find out, how do you find an inverse function of another function? How do you find one? So that's what we're going to do. And basically, we're going to have a three-step process. So basically, we're going to start off with the function f of x. And we're going to rename the f of x y. And then after we do that, we're going to solve for the variable x. And once you get the x all by itself, you're just going to rename it f inverse of y. And that'll be the process that we follow. So it seems simple enough, but there's a lot of tricky algebra oftentimes in doing it. So I'll just do a couple of exercises here. Let's say the instructions are to determine the inverse of the function. Okay, so I'm going to start with, I'll start with simple linear functions. These are actually really easy to do to find their inverses. We're going to start off with 22x minus 11. So the first thing I'm going to do, step one, I'm going to rewrite this f of x here as y. So I got y equals 22x minus 11. So we know that's a line. Now, if I wanted to solve for x, I would have to get x by itself, right? So I'd have to add 11 to each side. I get y plus 11 equals 22x. And then I divide both sides here by 22. So I'd end up with x is equal to y plus 11 over 22. And I'm now the third step. So that's the hardest part, is solving for x. Solving for x. Now the third part is rewriting x as f inverse of y. So we're going to say this is f inverse of y equals y plus 11 over 22. That should be a 22 right there, not a 2. That's the inverse function. Now, there are some people, they just don't like the idea of having y here as the input. So there are some people that will go ahead and rewrite this as f inverse of x equals x plus 11 over 22. You can do that if you want. You can make the input x, but I mean, y and x are just kind of dummy variables here, but I'm not going to be doing that. I'm just going to leave it as y for now. Now, if you wanted to graph this f inverse, y plus 11 over 22 on the same coordinate axes as the original function, you would want to turn it into x rather than to keep it y. But we're not doing that. We're not going to be graphing them, so I'm just going to leave it as it is. But the y is there. Okay, so I'm going to do a number 2. This one is not linear. This is going to be some type of cubic equation. We're going to have 4 times x plus 2 cubed minus 1. So the step 1 is to rewrite the f of x with a y. Keep everything else the same. Step 2 is to solve for x. So I want to get this x here by itself. So to get x by itself, I'm going to add a 1 to both sides. So I'm going to get y plus 1 equals 4 times x plus 2 cubed. Okay, now I have to get rid of this 4 right here. So I'm going to divide both sides by 4. And the 4's cancel, and I'm going to get y plus 1 over 4 on the left equals x plus 2 cubed. And then we're basically going to take the cube root of both sides. to get rid of this cube right here on the right. So take the cube root, and I'm going to get the cube root of y plus 1 over 4 equals, so basically the cube root and the cube cancel, x plus 2. And finally, I have to subtract 2 from both sides to get x by itself, so I'll get that x is in fact the cube root of y plus 1 over 4, and then minus 2. And then I'll rename this x right here. I'll call this x, this one, I'll call that f inverse of y. So f inverse of y is the cube root of y plus 1 divided by 4, and then separate from the radical is that minus 2. That's an inverse function of our original function. Okay, let's do one more here. Number 3. Well, we'll call this one g of x. So g of x is 2x minus 1 divided by 5x plus 2. So remember, your first step is always to rewrite your function, which in this case is g of x. Rewrite it with a y, and then we'll have y equals 2x minus 1 over 5x plus 2. Now the next step is to solve for x. Now be really careful. This is where it gets tricky solving for x. So notice you have this x stuff on bottom here, and if you want to solve for x, you want it to be up top. So how do I get rid of that bottom there? How do you get rid of a bottom? How do you get rid of a denominator? Well, you multiply both sides by it. So I'm going to multiply both sides by 5x plus 2. Whereas that basically cancels the 5x plus 2's on the right, and we're going to have, let's see, 5x plus 2 times a red y equals 2x minus 1. Now the problem here is we want to get x by itself, right? We want to solve for x, get x by itself. We really can't do that very easily with the way these parentheses are around the 5x plus 2. So we got to get rid of the parentheses around 5x plus 2. So we have to distribute the y here. I'm going to take y times 5x is going to be 5xy, and y times 2 is going to be plus 2y. On the right side, we're going to have 2x minus 1. So the idea is you want to get x all by itself, so that means you got to get all the x's to one side. So what I'm going to do, I'm going to get all the x's on, let's get the x's on the left side. If I want to get the x's on the left side, I want to subtract 5xy from both sides, because they all have x's. So I'm getting rid of the x's from the left. I'm getting all the x's on the right. All the x's on the right here. So here the 5xy and the minus 5xy cancel. I get 2y equals 2x minus 5xy minus 1. Okay, so we got all the x's here on the right. That's good. Now we're going to get rid of the minus 1 there on the right. We got to add 1 to both sides. So you want the x's on one side, everything else on the opposite side. So here I have 2y plus 1 equals 2x minus 5xy. So that's fantastic, right? All the x's are on the left, and now we can just factor out an x that's in common. Notice that these both on the right have an x in common, so we can factor that out. Factor out an x. What happens when you factor out an x? You put a parentheses and you can write 2 minus 5y. So x times 2 minus 5y is the same thing as 2x minus 5xy. And on the left, we have 2y plus 1. And if we wanted to get the x by itself, on the right, that's the goal, right, to solve for x, we divide both sides by 2 minus 5y. So finally, we can cancel out this 2 minus 5y. And we get that x here is, by itself, 2y plus 1 over 2 minus 5y. And now, finally, that we solve for the x, we can rename x f inverse of y. So f inverse of y is 2y plus 1 over 2 minus 5y. And there's our inverse function of f of x. It's f inverse of y. So, I mean, there's a little bit of algebra, quite a bit of algebra involved. You have to be really careful. So the goal is always to get the x on one side, all the x's on one side and the non-x's on the opposite side. Once you have all the x's on one side, you factor out an x, and you can divide out by the factor that doesn't have any x's in it. And you get the x by itself, and then you just rename the x f inverse of y. There's one more thing I want to say about inverse functions. Inverse functions. So I want to talk about graphing inverse functions. So essentially, what you're going to do when you're graphing inverse functions, let's say you have y equals f of x is your original function. And then you find an inverse function, which is x equals f inverse of y. This is the inverse function. Now, if you want to graph them on the same axes, if you want to graph these on the same axes, what you have to do, you have to take the inverse function, you have to switch the role of the x and the y. So you write this as y now equals f inverse of x. So this is an inverse function with the x and y swapped with x and y swapped. So you have the same basic underlying relationship, except the x and the y are swapped. So if you want to graph inverse functions, to graph an inverse function, you swap the x and y of the original function. Let me just do some examples of that. So some little examples. Given y equals f of x, graph y equals f inverse of x. Okay, I won't even use that. Okay, let's say this is our y-axis and this is our x-axis. And let's say this is here my original function. F, y equals f of x. And let's say this point here is, I don't know. It's not a very good drawing. Let's redraw this a little bit. Good to redraw this. That'll work, I guess. Okay. 1, 2, 1, 2, 3, 4. I should go up to 4 here. Garbage. Okay, let's say this is my original function, y equals f of x. So if you look at the points here are what? 0, 0, 1, 1, 2, 4. So basically to find the inverse graph, you're going to swap the x's and the y's. So I'm going to do the inverse in blue. So you swap the x's and the y's, you still get 0, 0. You swap the x's and the y's, you still get 1, 1. On this last point, though, 2, 4, if you swap the x's and the y's, you're going to get 4, 2. So I swap these x's and y's, I get 4, 2. So where's 4, 2? That would be right here. Now what happens is you're going to get a mirror image about this diagonal line here. So imagine there's a diagonal line right here. This is the diagonal line y equals x. Y equals x is that diagonal line. You know, basically, I want a mirror image about that from my blue one. So a mirror image would look something like, you got to have your blue points connect. Do something like this. Something like that. It's not great, is it? Let's try this again. This would be y equals f inverse of x. So you swap all the x's and the y's. And when you swap the x and the y's, you get sort of a mirror image about this dotted green line, which is y equals x. I don't like my graph so much, but I'm not a great grapher. Let's see. Let me try that one more time. Something like that. Something like that. Y equals f inverse of x. Okay, it's an attempt. Okay, number 2. Let's just do another example. Let's say my original function does something like this. So it's not curvy, it's kind of square, and that's it. That's just my function. So it has these little pieces to it. And let's talk about what points are here. This is the point -2, -1, right? This is the point -1, 0. This is the point 0, 1. And this is the point 1, 3. And this is the point 3, 4. So basically what we're going to do to find the f inverse function, we're going to swap out the x's and the y's. So I take this point on the left, it's -2, -1, and when I swap those, I'm going to get -1, -2. So that would be like here, right? -1, -2. Now I'm going to take -1, 0. I'm going to swap those out. I'm going to get 0, -1. Now I'm going to take the red point, 0, 1. I'm going to swap those out. The x's and the y's, I'm going to get 1, 0. That would be right here. I'm going to take 1, 3 and swap those out. I'm going to get 3, 1. That would be here. And I'm going to take 3, 4, swap those out. I'm going to get 4, 3, 1, 2, 3, 4, 3. That would be like right here. So I'm swapping my x's and my y's. Now imagine that you have this line here. I'm actually going to draw it. There should be a mirror image about this line right here, y equals x. So we want a mirror image, so do something like this, connect those, connect those, connect those, and connect those. And there's your inverse function in blue, y equals f inverse of x. Something to that effect. Yeah, so I don't think I actually ask you to graph any inverse functions, but this is how it would be done. You're swapping out